This is topic 1.1 for our chemistry course, the scope of chemistry. So our learning objectives for today, basically what I am going to be testing you on. Define three things. First off, define matter. Now, matter is anything that has mass and can occupy a certain volume in space. So something like a brick of charcoal would be matter because it has mass, you can weigh it, and it occupies space. There's a physical space occupied by that brick of charcoal. Helium also has mass. It's just lighter than air. So that is still a mass. So it occupies the volume inside a balloon. That is also matter. Matter is pretty much everything. Chemistry studies matter. And it studies the composition of matter. It studies how matter changes. You can see physical and chemical reactions and changes. We're going to be looking at those in another lecture. Two types of chemistry we're going to be breaking things down into are organic and inorganic. Organic chemistry is any chemistry that involves carbon. So if you're looking at that charcoal briquette, that actually has carbon in it. So we would be studying organic chemistry if we looked at what's going on in that charcoal briquette. Studying a bunch of lithium metal is not organic chemistry because it does not involve carbon. That would fall under inorganic chemistry, which is anything that does not contain carbon. Organic chemistry has a lot of overlap with biology, which is one way we're going to relate chemistry to other sciences. We're going to look in this very short lecture about the big pictures and the big ideas in chemistry, and one of those is going to be how it relates to other sciences, and describe how chemists investigate the world. Specifically, we're going to look at two different types of chemistry. Pure chemistry is just looking at chemicals because they're interesting and they're good for their own sake. So trying to discover new elements is going to be a form of pure chemistry. Applied chemistry has a practical goal or a practical application in the world. So studying the mechanics of Kevlar would be practical chemistry, or a faster chemical reaction to make hydrogen gas is practical chemistry. So I'm going to move quickly through these slides because there are a lot of activities we'll be doing in class, like individually defining chemistry. I just did. Chemistry relates to other things, and in class we're going to be discussing how it relates to something, say, math. You're going to get to know that way too well in this class because chemistry has a lot of relation with math. You need math to do chemistry, to do things like stoichiometry in chapter 12. It's going to be a lot of math, so be prepared for that. Physical science. Physical science has quite a lot of overlap with chemistry. You're going to notice that if you've taken physical science before, the first couple chapters are very similar. We'll be talking about lab safety, how to do things as a scientist, and of course the physical properties of things. These are all overlaps with physical science. Now, physical science moves on more towards physics, and chemistry moves more towards, well, chemistry. But chemistry still does have an interaction with physics. The mass of things is going to come up in momentum, and determining what the mass of something is depends on what elements it's made of, so there is an interaction with chemistry there. We're going to see the interaction in nuclear chemistry and nuclear physics are tightly tied together. Biology, well, the organic chemistry has a lot to do with biology because we are carbon-based life forms. Things like photosynthesis are chemical reactions and can be expressed through chemistry. I used to teach biology, and one of the things we would need to discuss is biology is applied chemistry. You need to know your chemistry to really understand your biology. As far as forensic science, well, dosage comes into play, and the dosage of different chemicals is going to have different effects on the body. So things like poisonings may be a forensic science link to chemistry. Let's look at the big ideas, and that's going to be opening up your textbooks, and that will be the big ideas in chemistry in section 1.1. In class, we're going to summarize it in our own words, but here I'm just going to quickly go through these from the book. The first one is chemistry as a central science. So how I just described that chemistry interacts with so many other sciences kind of posits that chemistry is something you need to know if you're going to really do well in other sciences. Electrons and the structure of atoms are another big idea. We're going to spend a large amount of time on what electrons do within atoms and how electrons interact within molecules. You'll actually see a lot of the learning objectives we have that are related to larger course objectives and what you're supposed to learn in chemistry in high school are about electrons and how electrons interact. Bonding and interactions. Well, most elements exist in compounds. So oxygen is not just a single atom. Oxygen is a compound made of two atoms stuck together, both, of course, oxygen atoms. But these ideas of interactions and bonds between atoms are important in chemistry. How do we get these bonds? Well, that's something called reactions. So chemical reactions are going to mean we start with certain things called reactants, and we get other things called products. And that is going to be a chemical reaction that will have a certain amount of change going on. Chemistry studies the change in compounds. That's going to be the change in matter. That's going to be the change called a reaction. Kinetic theory. So particles are always in motion. Temperature is a measure of the motion of particles in a substance. And that temperature determines whether something is a gas with very fast moving molecules that are not well attached to each other, a liquid, or a solid. Another big idea is the mole. Not the squirrel, the mole. Mole in quantifying matter. The mole is a way of measuring how many atoms are in a given amount of a pure substance. So that's going to be useful to actually, well, we're going to count atoms. I mean, not, grab them and roll them out on the desk, but we're going to know how many atoms are taking part in a reaction. And that's a good way to standardize reactions and calculations in chemistry. Matter and energy. Well, chemical processes produce energy, or they take energy. And we're going to look at exothermic and endothermic reactions. Reactions that give off or take on energy. And that's going to be something you'll study more in college about how energy interacts with matter. But we will be looking at how electrons give an atom more or less energy and how we actually move photons around as well. And last big idea would be carbon chemistry. That is organic chemistry. Many new carbon-containing compounds are being invented all the time. You're going to see a lot of these flavors we put in vapes. Well, those are actually carbon compounds created by chemists. That's right. Chemists study how to make vape pens and how to make ones that smell more like cotton candy or more like strawberries. That's carbon chemistry. And that is going to be an essential part of our chemical story.